All right, guys, so let's talk about doing some operations with functions, right? So, of course, operations that we are all very familiar with: addition, subtraction, multiplying, dividing, stuff like that. Another one that we'll see towards the end is called composition of functions, where you kind of substitute one function into the other. So it's kind of interesting as well. But the good news, most of the stuff's pretty straightforward. The composition's a little trickier, but let's jump right into it. Let's say we have two functions, f of x and g of x. And let's say that you want to find a new function, f plus g of x. So like you could think of this as like, I don't know, let's say f of x was like your earnings on one of your companies or whatever, and g of x was your earnings on the other. And you want to get a combined total earnings. So instead of finding the two individual values and then adding them together, you could instead come up with a new function that you would just plug in an x value and get the answer in one step. And basically it's exactly like what you would think it would be. F of x and g of x, if you want f plus g of x, all we're going to do is simply take the f of x rule and we're going to add whatever the rule for g of x is and just simply combine like terms. Okay, so we do want to write these in standard form, means get your biggest exponent first and just work your way down. So the 3x squared plus 2x, we can combine then the 6 and the 1. Okay, and this would be a new function, which would be the sum of the two original functions. Okay, one other thing I probably should have mentioned, when you're reading, just like you read any of this stuff, like you read this as f of x. Okay, it's not f times x. The notation is there basically. Let's just do a little side example. If f of x equals 2x plus 6, the notation, function notation, is designed to be a shortcut for you to say, for example, what would f of 3 be? Okay, so it's just a way for you to say, all right, I want the y value for a given x value. So when f of 3 would be 2 times 3 plus 6. Okay, so 12, or I'm sorry, 6 plus 6 would be 12. So the reason I'm pointing that out is because sometimes when people are doing, when it gets a little more complicated, when it's like f plus g, it's still f plus g of x. Okay, this is not another thing we're multiplying by. This is just saying like that's the variable that you could plug something into. Okay, so like if we wanted f plus g of 2, we would just plug the 2 in there and there, goes for both x's, and we could get a y value to go with that. Okay, just wanted to point that out. Part B, if we want to do f minus g of x, okay, so with subtraction, same kind of thing. Make sure the order is important though with subtraction. There's f of x minus, now g of x needs to be put in parentheses. Okay, and the reason why it's important is with subtraction, you're actually subtracting each of those terms. So if you don't use the parentheses, okay, you might miss that this last sign here needs to be a minus 1, not a plus 1. Okay, and that's just one of the common mistakes that I see. So when we go to finally simplify, again in standard form, the biggest term is negative 3x squared. We have a positive 2x, and then we have a plus 6 and a minus 1. Those combine to become a plus 5. Okay, that is f minus g, again, of x. We're not multiplying another x out or anything. That's just saying that would be the variable that we could plug in if we wanted to, like I was showing you down here. Okay, we can also do multiplication and division, and there again, probably like you would expect, we're just going to multiply the two functions. So the closed dot, of course, means multiplication. So kind of watch out when we get to the last part. There's a slight difference in the symbol, but this is multiplication. Okay, so we have 2x plus 6. That's f of x. G of x is 3x squared plus 1. Okay, again, we're kind of ignoring that x for now. That's just saying that's the variable in the problem. And now we need to multiply this all out. This is going to be a distributing problem. And this one, like specifically, more like a FOIL problem. So I'm going to take the 2x times the 3x squared. So we're going to multiply the 2 times 3. And then the x times x squared, we add those exponents. It does become x to the third. Then we will do the 2x times 1. Okay, then we will move on and distribute or multiply the 6 to each of those. So plus 18x squareds and plus 6. Okay, and we're just about done. We just would like to write this in standard form, so we're going to get the exponents in order. 6x cubed, then we'll write the plus 18x squared, plus 2x, and plus 6. Okay, and that is it. That is our answer. Again, I keep saying this, but we are not multiplying by that x. Okay, that x is just saying you could plug a value in for it at some point. All right, the division problems. Okay, for now these are going to be real quick. To do a division, all we're going to do is do f of x over g of x. Okay, or whatever order it's written in. This one they want f of x as the numerator, so 2x plus 6 over g of x, 3x squared plus 1. Okay, and we're kind of going to stop with that. We don't have to actually do any division, okay, at this point. Down the road, we're going to talk about how to divide polynomials and all that stuff. But there is one little detail here, and the detail is whenever you have a fraction or a division problem, you can never have a 0 in the denominator, right, of a fraction, right? Something over 0 is undefined. So with the division problems, there's going to be what's called these excluded values or restricted values. Okay, and what that means is some values of x will make the denominator 0. We need to state what those are. Okay, so we're going to say something like 3x squared plus 1 equals 0, and we're going to solve it. Okay, just the denominator. Don't even worry about the numerator. So this is the expression, but the excluded values come from this little equation. Okay, and this is actually going to be a little more complicated than I wanted it to today, but okay, let's just say for now, x, to solve an x squared equation, we do take the square root of both sides. So x equaling, it can be a positive and negative square root of negative 1/3. Again, I didn't want this to get too complicated with the square roots and square roots and negatives, because technically there's more going on there. But generally, whatever's in the denominator, you just need to set it equal to 0 and state those x values as what are called excluded values. Okay, so it'll be a simpler denominator where it won't be x squared in there and getting a negative and all that stuff. But just be ready to state that. The directions may say, simplify. Okay, if it says simplify, this is it. And state excluded values, there they are. Okay, and again, those are the x values that would make the denominator equal to 0, which would cause this thing to be undefined. So technically, those values are excluded from the domain, because if we were to graph this thing, for those given x values, we would have an undefined expression. And now again, this one's kind of weird because it's the square root of a negative number. So more on that later. Don't worry about that. I didn't plan on making that overly complicated. But just be ready to solve the denominator equaling 0 for the fractions. All right, and last but not least, one new operation, which we'll see some applications of shortly. But basically, it's this idea of an open circle. And what that open circle, the way it's read, it's pronounced, it's composition. This is composition of functions. Okay, when you compose functions, you basically end up plugging one into the other. Okay, so this is read as f of g of x. Okay, f of g of x. So what it really means is f, okay, of g of x. Okay, and the other one's just the other order. It's g of f of x. Okay, so let's talk about how do we handle that? What do we do with these? Okay, so if I asked you for, let's just do a little side note again, specifically we did before, like f of 2, for example, right? F of 2. So you would go up here to the rule of f of x, and you'd say, all right, f of anything, f of x is 2 times x plus 6, so this is 2 times 2 plus 6, which is 4 plus 6, which is 10, right? So basically, f of anything, okay, f of x, that's where you put the x, right? It's 2 times the thing plus 6, okay, for this specific problem. So let's think about this. Okay, in this case, the thing that we're going to plug in is g of x. Okay, so g of x is 3x squared plus 1. So let's start with that first. Okay, let's substitute, this is called the inside function. Right? G of x is like inside the parentheses. So g of x is really just 3x squared plus 1. Okay, so we got that substituted. Now we're just going to say, all right, f of anything is 2 times that thing plus 6. Okay, so f of this stuff will just equal 2 times all that stuff plus 6. Okay, notice I just took the x and I plugged it in right there in that format, right? It's 2 times the thing plus 6. So make sure you're seeing where that's coming from. It just seems weird because it's not like just a single value. It's just an expression. And all we need to do now is simplify that. Okay, we're going to distribute the 2, 6x squared plus 2. And then there's a plus 6 at the end. So our final answer would be 6x squared plus 8. Okay, that would be considered f of g of x. Okay, let's do the other order so we can kind of see how that looks too. My eraser. There we go. All right, so let's do the other order. G now of f of x. So g of f of x, again, is g of, we're going to replace f of x with the 2x plus 6 that they gave us. Okay, so we have g of 2x plus 6, right? Now you got to ask yourself, okay, what is the rule for g of x? Right, g of anything is 3 times that thing squared plus 1. So this 2x plus 6 is what's going to go in for that x right there. Okay, I'm just going to follow that format. It's 3. I'm going to put in parentheses because it's an entire expression. 2x plus 6 all squared plus 1. Okay, again, look at the rule for g of x up top. It's 3 times the thing squared plus 1. Okay, so now we got to simplify and we got to be a little careful here. Okay, let's see what we got. We have order of operations, right? We have something being squared. I'm going to write the 2x plus 6, since it's being squared, I'm going to write it as times itself. Okay, because when we square that thing, it is not just going to become 4x squared plus 36. Okay, that's a common mistake. Since this had 2 terms, in 2x and the 6, we actually need to FOIL it out and distribute the whole thing. So let's leave that 3 alone that was there. Okay, let's multiply out I'm going to distribute or FOIL these 2 things together first. Okay, and you don't have to do it in that order. I'm just doing it in that order. Okay, so the 2x times 2x is 4x squared. The 2x times 6 is plus 12x. Then we distribute this 6 times 2x is another plus 12x. And then the 6 times 6 is plus 36. Okay, close the parenthesis, and there's still a plus 1 sitting outside everything. Okay, then we can keep simplifying. The 3's still out there. In the parentheses, we have 4x squared. We can combine the 12x and 12x to become 24x plus 36, and then there's still a plus 1 on the outside. Okay, now what we can do is distribute the 3 to everything. So 3 times the 4x squared, we have 12x squared. 3 times the 24x is 72x. 3 times the 36, let me just make sure, I think it's 109. 108, sorry. Plus 108. And then there's a plus 1 sitting on the outside as well. And our final answer is 12x squared plus 72x plus 109. Okay, so that is composition of functions.